Hello, everyone. Welcome. I was actually talking to a few people last night, and the conversation was about how interactability is so important for today's modern web applications. And quite quickly, the conversation translated into, well, what does it mean in terms of response times for web applications, and are those response times even achievable? There's obviously quite a bit of research that has happened in this area, and it's generally accepted that anytime when your response times are more than 100 milliseconds, your users start getting disengaged. If you look at the speed of light on glass fibers, if you had to go around the globe, it's going to take you about 220 milliseconds. So it's well within the realm of possibility. That's good. That's a good sign. If you look at today's modern-day applications, they have about 50 to 100 objects in each of their web pages, which means that for you to actually give a performance that's acceptable, you have to continuously invest in making your applications fast. Right? In 2006, Forrester Research released an article which said that at about 4-second response times, your customers start abandoning your web pages. Just about 3 years later, they published another article which said that time has shrunk to about 3 seconds. So in 3 years, a 1-second reduction in how fast your applications have to be. Generally, today, it's an acceptable rule that you need response times well below 2 seconds. In fact, many human-computer interaction experts say that a 2-second response time is such a low bar, and you need to go faster. Now, we all have great applications. We have competitors who actually have good applications as well. And you don't have a choice but to continuously invest in making your web applications faster. Because you know what? Your customers are going to come and tell you, your applications are great, I love it. But they're never going to come and tell you, I just wish you made it a little bit slower. You're never going to hear that comment. Right? On that note, folks, my name is Kalyan Raman Prasad. I run the Edge Services department at AWS. I'm going to be doing a presentation on building lightning-fast applications with CloudFront and Route 53. I'm going to be doing it with Parviz. This is my colleague here. And let's get started. So what are the main fundamental facts that you need to take into account when you build web applications? Well, the first and foremost one is tight security. Your customers expect that of you. Okay, you can provide them nothing less than airtight security. Right? The next one is availability. Okay? You have to make your applications statistically indistinguishable from near perfect. And finally, unmatched performance. Well, if your applications are not available, it does not matter how good your performance is. So availability is super key. Okay? Now, how does AWS help? And Parviz will go into a lot more depth here, but I'll give you 4 practical suggestions. The first one is using Amazon's Route 53 DNS layer. It's called the DNS failover capability. What this lets you do is it actually has a paradigm shift in how you can actually design for high availability. What we expect customers to set up with DNS failover is that you actually pre-configure your applications, whether it's hot standby or hot-cold standby, you pre-configure applications right at the time of setup, which means when you do have a failure in your application layer, you're not actually going and addressing it by changing the control plane, either at DNS or your application layer. Right? The DNS system automatically moves your assets or your end users to performing applications. The next one is the use of CloudFront with custom error pages. Now, this is a feature that we released fairly recently. What this lets you do is it lets you configure your web application such that you get the illusion of highly available site. That means even if your site is down and your applications in the back end are down, you can give the illusion that the sites are still functional. Okay, and this gives you a little bit more time to go and troubleshoot your applications. The last suggestion I would have is the fact that CloudFront is essentially a cache, which means that if your origins are down, we are going to be serving stale content to your end users. So your end users still see that your websites are still functioning. Well, why does performance matter? Your applications are now global, which means that your end users are not in specific geographies. You need your end users to be accessing your application from throughout the globe, right? And customer engagement is key. A better, faster, highly available application increases your customer adoption, increases your engagement, increases the page views that you actually see. In fact, one statistic puts it as a second delay in your web application layer translates to about 7% loss in revenue. Okay, so if your site is doing about $100,000 every single day, that's about $37 million a year. $2.5 million is the potential revenue loss when your applications are not performing at the web application layer. So how do developers actually address this? Most developers spend a lot of time and energy going and optimizing the server-side components for improving performance. Now, that's a good thing. You have to continue to do that. There are reasons why developers do that, and it's because your server-side application layer is always better instrumented than your web application layer, right? So when it's better instrumented, you know exactly where your bottlenecks are. It's easier to actually work through it. It's easier to know exactly where you need to spend your efforts on, okay? But 80% of a user's perceived latency actually comes from the web tier, okay? So you have to continuously invest in making the web tier performant, because that is something that's the face of your entire offering that you give to your customers. So how do we improve performance? Well, before we get to that, let's talk about the typical anatomy of a web application. There's two major categories. There's static content, and there's dynamic content. Static content is something that most people are familiar with. This content typically has high TTLs. You also have some form of static content that has low TTLs. And then there is dynamic content, which is typically objects which have 0 TTL. That means it's not cacheable. Here are some examples. High TTL objects, images, CSS, JavaScript, and low TTL objects, and this is an Amazon.com website, and what that section down below talks about, it talks about recommendations based on your browsing history. If you think about it, that really does not have to be real time. You can cache that information, although for a smaller period of time, of the order of a few seconds, it's still cacheable. I'm not going to go into too much of detail with this architecture, but this is something that's very common. People put a CDN, like CloudFront, in front of static assets. Static assets are stored in S3 or a custom origin. You serve your website through CloudFront for the static assets and the low TTL objects. For dynamic objects, you directly go to either EC2 instances, ELB instances, or your custom origins. Dynamic content cannot be cached, okay? It's something that has 0 TTL. But if you look at what this content is, it's personalized information. It's account information, it's shopping cart information, it's personalized pokes. It's something that your customers really care about. In fact, I don't think I can think of any web application today that does not have a component of static and dynamic content. You rarely build web pages with just purely static content, okay? So your end users care about this content. It actually affects 100% of your pages, and it's something that you need to spend time improving at the web tier as well. So the question that we should be asking is, why wouldn't we put a CDN like CloudFront both in front of your dynamic and your static pages? And when we propose this to many of our customers, we actually get 3 distinct answers. why don't customers use a CDN for dynamic content? And by far, the largest reason why customers don't use a CDN for dynamic content is because they're not sure what the value of a CDN is, okay? You're going back to your origins for every single request. CDNs are typically supposed to be caches, so what value does it give you? That's a common expectation that customers have. That's a common reason that they provide as to why they don't use a CDN, okay? The second reason they give us is the small set of customers who come and tell us, no, we see the value of it, but you know what? Dynamic content acceleration is a premium product, okay? It requires expensive professional services. It's not something that's available for the masses, okay? It's not something that's common to use. It's not something that's easy to use. And they come back and say, that's why we don't use a CDN for dynamic content. Well, let me tell you what the benefits are. I'm going to quickly go through what the benefits are and hand it off to Parviz to go into the depths of these reasons why you need a CDN for dynamic content. The first one, or the first two of them, actually, are TCP optimizations. So if you look at it, your end users are connecting to edge servers distributed throughout the world, okay? Those edge servers connect back to the origins using highly optimized TCP connections. That means the window sizes are already scaled. It's persistent connections. It already gives you a benefit in terms of reducing your round trip time, okay? The third reason here is SSL termination. If you look at the trend for where web applications are going, almost all web applications are requiring that you secure the delivery to your end users, okay? So one of the biggest benefits that you get by having a CDN in front of dynamic content is termination of SSL right at the edge, which means that the long connections that you have from your end users back to the origins are reduced down to shorter connections to the edge locations, right? Recently, we released put and post support. In fact, it's broader HTTP support, put, post, patch, delete, and options. And the same benefits of SSL termination, TCP window optimizations back to the origin are actually available as part of these broad HTTP web support in CloudFront. The next one is latency-based routing. And latency-based routing is the concept of using a service like Route 53 that picks the right origin that you need to go to. So imagine your end users are connecting to edge servers which are distributed through the world, and you have multiple origins for high availability. Once you use Route 53 and CloudFront in conjunction, CloudFront can connect to the right origin based on Route 53's answers, okay? That's actually a pretty intense topic, that and the DNS failover. We actually have a separate session on this. I encourage you to go see that session. It's on Friday at 1:30. It's called Architecting for High Availability using ELB and Route 53. Pretty interesting session. We figured it's important enough that we need to have a dedicated session for it. And the last one is low prices, okay? Our dynamic content feature in CloudFront does not cost you anything more than your static content feature, okay? That's actually a huge benefit because the first reason that customers gave was a technical reason. We're going to go into the depths of it. The next two reasons were economical reasons, and we've addressed it automatically. Okay, we don't see a reason why we need to spend more money, or you guys need to spend more money accelerating dynamic content by using a CDN like CloudFront. With that, I'm going to hand it off to Parviz. We'll give you more details about all those topics I talked about. Thank you, Parviz.
Thank you, Prasad. Hello, everyone. All right, well, hope you guys are ready for a ton of technical stuff, TCP IP optimization, latency-based routing, packet optimization, everything that you can think of. It's always hard to go after Andy's keynote. I'd actually have two options, after Andy's keynote or after Thursday's parties. I wasn't sure which one is best, so I picked this one. So again, I'm going to go through a lot of technical discussions, a lot of technical details. Before I get into that, I want to get into talking about reusable static or static contents. I think it's really important for us to define that. And let me actually first define it. The way I define static or reusable content is given a content where state of the content doesn't change for a specific period of time. I want to focus on that specific period of time. It's really important. I don't know if you guys noticed, I didn't say images, I didn't say CSS, I didn't say JavaScript. I don't want to confine myself to a specific content type. That's what a lot of customers get into trouble. I'm a solution architect. I work with a lot of customers, and we get into architecting their infrastructure. We get into diagrams, and I see a pattern emerge, and I say, well, are you using CloudFront for this pattern? And they typically say, no, I don't have images, I don't have CSS, I don't have JavaScript. And that actually kills me, because that's not what CloudFront is only good for. CloudFront can do a ton of things. And if you start not to define yourself just for images and JavaScript, and not to use CloudFront just for that, you open yourself up to a lot of optimizations. And the next content would be, a type of content would be unique or dynamic content. That's the content where you create it. As soon as you create it, the state of that object changes, meaning that something in that object changes, so it doesn't stay the same. And as Prasad was mentioning, it is probably not a good thing to cache. You have to proxy that back to your infrastructure, and we'll talk about what kind of optimization you can do on this content. So I have an example site that I want to use today. I've seen this site before. I'm not sure if you guys have seen it, but I've seen it before. But it's an example website. Dynamic content in this case would be index.jsp, so just the wrapper around the site, the first thing that comes. And the embedded content would be the static content, so JavaScript, CSS, or anything else, and we'll get into the other types of content. So if I do my performances, and I've actually done this, it's not a fake number. This page takes 1.5 seconds to download or to render. Well, I don't know if you guys pay attention. Prasad was talking about this research, and if every second of delay, you can be losing about $2.5 million of sales. And imagine if Prasad is my boss, comes up to me and says, hey, Parviz, we have a 1.5 second page load time. I've seen this research. If you shave off a second of this page load time, we could be gaining about $2.5 million in sales. So that would be my goal for the rest of this session. So that's me. I'm going on a whiteboard doing a lot of brainstorming, and I come up with 2 very genius ideas: accelerating static contents and accelerating dynamic contents. So before I get into acceleration discussion and all the technical details of that, I want to introduce you guys to my favorite tool, which is Waterfall graphs. Waterfall graphs is by far the most important web performance measurement tool. Most browsers have it as a plugin, so you can think of Firefox, Chrome, Safari, they all have it. And the reason I want to go through waterfall graphs is that it gives me a clue as to what happens between the time when you guys type something in the browser and when the actual browser renders the page and you actually see the content. So it's really important for me to understand what happens. And if I can understand what happens, I can start optimizing my content. It typically looks something like this. The first bar would be the first thing that gets loaded, so index.jsp or anything else, just the wrapper. Everything preceding that would be anything embedded within that page. And the order of that, again, the first thing comes and then everything else, and how large or how the length of the bar would be how long that content took to download or to render in browser. Each bar consists of multiple components: DNS lookup time, TCP connection time. The TCP connection time is the handshake that happens between the end user and the web server. The time to first byte. This is an interesting component. It tells you how busy your server is. This is the time that when you send a request and web server sends the first packet back. So if the server is really busy, this first time byte would be a little bit larger. And the content download time, this is after the first byte's time and the actual content gets to the browser, so how long that takes. Again, to give you an example, the first bar would be index.jsp, would be the wrapper around all my content. Preceding content would be anything within that page, so all the images, images, CSS, JavaScript. All right, so let's get into optimizing my static contents. And I promise you, this is not going to be just the boring caching stuff. It's going to be a lot of cool stuff we're going to talk about here. But I do have to start with image and CSS and JavaScript. That's the easiest thing I can do. I'm just going to cache that on CloudFront, optimize it, and speed up the delivery of the page. Easy. I'm not going to spend too much time on this. But I'm going to give you a demonstration how it works, just if you're not familiar with it. The end user goes to CloudFront location, closest CloudFront location. CloudFront goes back to the origin to get the content because it doesn't have the content at the given time. The origin responds back with the content. Now edge location has that content. Content gets delivered to the end user. Now when the second user comes, well, I'm not sure what that is, but the content is there. The edge location, the CloudFront location responds back with the image. Now, the benefits of that is content is closer to the end user. And obviously, anything that's closer to the end user gives you better performance and better user experience. And also offloads your infrastructure from serving the same content multiple times. If it's the same content, why do you have to serve it multiple times? Offload that to CloudFront. Now, again, remember this was the example page that I was showing you guys. 1.5 seconds, actually it was 1.4 seconds, but let's just round that up to 1.5 seconds. The page load time. This is the actual test I've done. I started caching with CloudFront. And after caching the content, JavaScript, CSS, and very simple stuff, my performance is at 770 milliseconds now. That's almost 90% of improvement just simply by caching. And I haven't done all the other optimization that I want to do. So I still have 200 milliseconds left. So again, am I done yet? I'm not. I'm not completely done yet. I still have the goal of half a second to meet. So the way I want to do that is cache as much as I can. Now, remember I talked about so caching as much as I can. And what else would I cache? I mean, I'm already caching images. I'm already caching JavaScript and CSS. What else can I cache? Now, one thing I could do is I can go back and look at my W3C logs, the web server logs that I have, and find anything else that's getting hit on my web server. So this is a simple report that tells me that all the stuff that you're serving, I can order that, and I can run a simple query. If you guys are SQL, familiar with SQL, this would be the simple query that you can run. Run it on RDS, EMR, Elastic MapReduce. You can run that on Amazon Redshift, or anything that you may have. Doesn't have to be those solutions. So I can run that and get a report similar to this, which would be an ordered list of content that I'm serving. Starts with index.jsp, all the JavaScript, CSS, GIF, and everything that I have. And a few other things that looks a little bit, I guess, strange. It doesn't look like GIF, JavaScript, or anything else. Looks like an API calls, so I'm not sure what to do with those. So I'm caching everything else, GIF, CSS, and JavaScript. But remember, the first thing I've started this conversation with is anything that the state, any content that the state doesn't change for a given period of time is static, it's reusable. With that definition, I want to get into, so with that definition, that opens me up to a lot of different choices. I can cache anything at this point. It doesn't have to be GIF, JavaScript, or CSS. It can be anything. It can be API calls. It can be almost any content type. And CloudFront can do that for you. CloudFront can cache for days, for hours, for minutes, and seconds. Doesn't matter. You just put a cache control header on top of it for a second or 2 seconds. And I talk about why even a second TTL is important to you guys. I'll talk about that later. But how about this content? Let's look at it. It looks strange, right? I mean, it's factor create image. It will create an image called name book 1 and a size 10 by 10. I don't know if you guys know this, but CloudFront can cache this content. It's getting hit 110 times. Why not cache it? CloudFront can cache anything with query string. If it has a query string, it can be cached. Don't be afraid of caching stuff that has query string in it. The only difference is that if the query string changes, for example, the book 1 becomes book 2, or the size changes, it creates a new object in cache. But you can cache that. Don't be afraid of caching anything with query string. How about this content? I mean, it has an API in it. I mean, a lot of people would be scared of caching this content because it's an API call. But there's a concept of read-heavy and write-heavy APIs. If you have a read-heavy API and the API is getting hit multiple times, don't be afraid of caching it. This API call is getting hit 100 times. I can cache it for 5 minutes, for 2 seconds, for an hour. You guys decide how long you want to cache it, but it can be cached. Same thing here. I'm getting, and this would be maybe a different API call. A different API call and gives me the top 10 popular books that I've been selling. And this could be, that can change every second. This can change every minute. But again, doesn't matter what it is. As long as the state of the object doesn't change, you can cache that content. So this is my favorite topic. I don't know if you guys think caching for a second helps. I talk to a lot of customers, and they don't think, and it just doesn't come to their mind, that you can cache content for even a second. So if you have something that's getting hit thousands of requests per second, that's 1,000 requests per second. But what if you can cache it even for a second? What happens is that all the users that will get to that content first will wait for the first user to respond back, and they will share the same object. What if you increase that to 2 seconds? That's thousands requests per 2 seconds. That would be 500 requests per second back to your infrastructure. Continue doing that. 1,000 requests per second, cache that for 3 seconds. That would be 300 requests per second on your infrastructure, on backend infrastructure. You continue doing that, and you're getting to a very interesting design pattern where if you have a hard-hit API, you don't have to send that directly to ELB. Cache that on CloudFront for even a second or 2 seconds. And I don't know how many of you guys you've done ELB pre-warming. It's maybe not a fun thing to do. But if you have a content that you're going to hit ELB too often, just put it in front of CloudFront. And you don't have to go through the ELB pre-warming anymore. And the last piece that we talked about, index.jsp, this is the first thing that comes, the first HTML page or JSP page that comes. It's a dynamic content. It's not cacheable. What do we do with that? So we talked about all the caching stuff. Now let's get into optimizing dynamic contents. So, and again, we've gone through this. Images, CSS, anything preceding the first bar, we already optimized. Now we have index.jsp. What can we do with that content? Well, as Prasad mentioned, dynamic contents are not cacheable. They're so unique that even if you cache it for a second or 2 seconds, the next second content changes. And because of that, CloudFront or any other CDN has to proxy that back to your infrastructure and proxy the content back to the end user. So, arguably, so arguably, I'm not sure if that adds an latency because you're now putting a CDN or proxy in between, and you have to go back and forth. Does that add latency? And this is how it's going to look like. The first user goes to edge location. Edge location obviously doesn't have the content. It's a dynamic content. Goes back to origin, gets the content back, gives it to the end user. Now the next user comes. Well, it's not cached. Has to go back to the origin, come back, get back to the end user. And again, does that add latency? I'm sure. I mean, it's not complicated. It does add latency if you don't add optimization on top of it. It has to go back and forth to origin multiple times. You incurred latency. So how do we improve that now? We're proxying that back and forth, so we see some latency if we don't do anything with it. So let me actually go back to the waterfall graph. If this is the waterfall graph, and if this is index.jsp, and it composes of multiple components, right? DNS lookup time, how long it takes to do a DNS lookup time to get to your infrastructure or resolve to an IP. How long it takes to do a TCP connection to your web server. The first byte, time to first byte, and also content download time. So arguably, if I want to increase or get a better response time for my dynamic content, I have to do either of these things. Either reduce my DNS time and or reduce my connection time and or reduce first byte time and or reduce content download time. I have to either do one, multiple ones, and all of them. If I can do all of them, perfect. If I can't, I have to do at least 1 or 2 of these components. So how do I do that? Reducing DNS time, super easy. You can do it with Amazon Route 53, and we'll talk about it. Reduce connection time. This is the handshake that has to happen. How do you reduce that? You can do that with CloudFront Keep Alive connections and SSL termination if you have SSL content. Reduce first byte time. How do you do that with CloudFront Keep Alive connections again? And we'll get into the details of that. And reduce content download time. You can do that with TCP IP optimizations that CloudFront provides, and also Route 53, and we'll get into it. So just a reminder, I'm 770 milliseconds. My goal is a half a second. So DNS, improving DNS time. This is the easiest thing you can do, and it's only a couple of slides, so I'll go through this. You can do this with Amazon Route 53. Amazon Route 53 is a managed DNS offering. It was designed to be fast, super fast, and low latency DNS resolution, and has a global network of DNS servers around the world. And the way it's fast and it's quick is because you get routed to the nearest and the closest DNS server. To give you an illustration of this, if this is what you're doing today, you may be using a DNS provider that has limited DNS locations. And what your end users have to go is they have to traverse all the way to that DNS server. Now, so if you have international locations or users further away from DNS, their DNS resolution will take a bit of a time. As compared to if you point your host name or your origin host name to Route 53, we have multiple locations, and you get routed to the closest location, so your DNS resolution time will definitely reduce. So that was it for Route 53. Simple, just point your host name or domain to Amazon Route 53, and that's it. We do every magic behind the scene. So how do we improve TCP connections and a first byte download time? We can do that with CloudFront's Keep Alive connections. So let me give you a little bit of overview of TCP IP, handshakes, and all that, and that makes it a little bit clear as to what are the drawbacks are, what are the penalties that you incur by running on TCP IP, and how to improve that. Every TCP IP connection that has to happen has to go through the first handshake, which would be SYN, SYN-ACK, and ACK back, and then the request can go through now. So that has to happen on every connection. And this TCP IP handshake process can penalize dynamic contents. And this dynamic contents are small, so if you have to make a connection multiple times, this handshake is just a waste of time. To give you an illustration of that, if the user wants to connect to your infrastructure, the user sends a SYN, SYN-ACK back, sends in another ACK, and the user sends another ACK. Now, at that point, only at that point, you can get index.jsp back to your infrastructure. Remember, you've done 4 round trips, and only on the 4th one, you can say, hey, give me get index.jsp, and you still haven't got the content. You're just making the request. So if the latency between end user and your infrastructure is 90 milliseconds, let's just take that as an example, that's 360 milliseconds that user has to wait before it can even send a request back to your web server. Now the second user comes. SYN, same thing, SYN-ACK, ACK back, get index.jsp. Another 360 milliseconds. And the more users you have, every one of them have to go through this. So again, every new user is a new connection, and every new connection has to go through this, and you have to do this all day with every end user. And what happens with that is that if you have a ton of users, and hopefully you do, you put too much load on your infrastructure. Memory, CPU utilization, all that will go up. And puts a load on your web server. And what happens is that when you put a load on your web server, the first time to first byte increases. And remember, I talked about this being a really interesting metric, which tells you how busy your server is. This is the server getting the request, going to do some sort of lookup to get the index.jsp back, and the first byte that comes. And it gives you an indication how busy your server is. So the more load you put on your infrastructure, the more TCP IP connections you have to handle, this increases. Now, Keep Alive connections can help us a lot, and the concept of Keep Alive connections is really simple. If I'm making the first connection, TCP IP connection, I'll keep that TCP IP connection open. I will never close it again. Maybe after some timeout, after 10 minutes, 5 minutes, you guys can configure that on your web server. But once I keep that connection open, I will use that for every other subsequent request. To give you an example. Same thing, SYN, SYN-ACK, ACK, data flows. Now, if the second user comes, I don't have to go through this handshake again, because my connection is already, TCP IP connection, connection is already open. I haven't closed that. So I'll send the request through, and I don't have to go through the SYN-ACK, ACK, all that kind of stuff again. So that's the Keep Alive connections. How does that involve CloudFront? So let's go through an example. If the end user, and again, in this example, the end user is getting connected to the closest CloudFront location with 30 milliseconds, and then CloudFront has 60 milliseconds back to your infrastructure. So again, the aggregate is still 90 milliseconds. We haven't changed anything. but the end user will get connected to CloudFront at 30 milliseconds. He'll do SYN, SYNAC, ACK, get index JSP. This is dynamic content, it's not cached. So CloudFront has to do the same thing. SYN, SYNAC, ACK, get index JSP back to your infrastructure, and data goes back to the user. So our latency is still the same, 360 milliseconds. So that's 4 round trips times 30, 120 milliseconds, another 4 round trips of 60 milliseconds for each round trip, 240 milliseconds. That's about 360 milliseconds for the first user. Now, what happens when the second user comes? SYN, SYNAC, ACK, get index JSP. Well, guess what? We already have a connection open from CloudFront to your infrastructure, so we don't have to do this TCP IP handshake again. So we simply send get index JSP back to your infrastructure. The second user, instead of having 360 millisecond experience, will have 180 millisecond. That's simple idea, but it works. 180 milliseconds for your dynamic content when you make a request to CloudFront. So just to summarize, more users, and with this pattern, with this keep alive connection, more users doesn't mean more connections. So 2 users will be 2 connections. And with CloudFront, again, with CloudFront, so without CloudFront, you will be 2 connections. With CloudFront, you will have 1 connection because we keep the connection open. And that offloads your infrastructure and also improves the latency time. So 2 users, aggregated 2 users had 720 millisecond response time. With CloudFront, the aggregate of 2 users had 540 milliseconds, so 360 milliseconds plus 180 milliseconds. I've done a test, so I'll go through this quickly because I'm short of time. But I've done a test. I've done a test where I've done a load test, sent thousands of requests, HTTP requests, to an instance sitting in AWS without CloudFront in between. I sent thousands of HTTP requests, and also do a second test with CloudFront in between. The difference is huge. With CloudFront in between, without CloudFront in between, my CPU utilization on that instance is about 20%. When I put CloudFront in between, I get 6% CPU utilization. That's all because I don't have to handle thousands of connections with end users. I only have to handle the keep alive connections from CloudFront to my infrastructure. All right, what happens if you have SSL connections? Everything we talked about was HTTP. What if you have HTTPS connections? CloudFront can terminate your SSL connections at the edge, and you can do that with CloudFront shared certificates, or you can bring your own certificates and upload that through IAM to CloudFront, Identity Access Management, to CloudFront. And the benefit of that is that SSL traffic gets terminated at CloudFront. Not only gives you better performance, but also gives you an offload that you need from your infrastructure. Very, very similar to the concept of ELB SSL termination. So if you're using ELB for SSL termination, this is the similar concept. And again, the benefits, a huge benefit of having SSL termination on CloudFront is, again, going back to the keep alive connections. Not only SSL has to do the same TCP IP handshakes, it has to do even more because of the certification exchange that has to happen between those two, between the end user and your infrastructure. So to eliminate that, you can have keep alive connections stay open, so you don't have to exchange certificates anymore, and send the request back to your through CloudFront to your infrastructure. There are 2 patterns here you can leverage: half-bridge SSL termination and full-bridge SSL termination. Half-bridge SSL termination is end users connect to CloudFront with SSL. CloudFront will downgrade to HTTP and connects to your infrastructure over HTTP. So it's obviously not a full end-to-end encryption. It's really useful for cases where you have websites that are the base page, index.jsp, the card, whatever the page you have is on SSL, and the embedded content, like let's just say images, has to be on SSL too, because if you don't, the browser gives you a warning message that says, hey, the embedded contents are not in SSL. So to get around that, I mean, images doesn't have to be secure. So to get around that, you can use this pattern. Just put everything on SSL in your page, have CloudFront terminate the SSL, but then when we go back to your infrastructure, we go over HTTP. And the big benefit of that is performance. If you do a performance test on this, it's great. It gives you great performance because we're downgrading to HTTP. It's just not a big magic. It's, instead of going over HTTPS, we go over HTTP. That gives you a better performance. But the next pattern would be complete full bridge SSL termination. And we can definitely do that. You connect to CloudFront through HTTPS, we'll send the request back over HTTPS back to your infrastructure. How do we improve content download time? We talked about DNS resolution, TCP connection. How do we do, and also first byte time, but how do we do content download time? How do we improve that time for you? All right, so this is, we do that with slow start optimization. And again, this is going to be a complicated topic. I've simplified it a little bit, so let's go through that. Slow start, what is slow start? Slow start is a TCP IP optimization where it limits what two users can do at a given time. So for example, if everyone in this room wants to talk all at the same time, it'd be a mayhem. No one can understand each other. Same thing goes over the internet. If all the hosts on the internet wants to talk to each other, if they all talk at the same time, at full force, at full bandwidth they have, the internet will go down. It will be a complete meltdown. To avoid that, they put in TCP Slow Start optimization. TCP Slow Start optimization is a way for two hosts to talk to each other at the slower pace. They start slow, and then they go much faster. So this is how it works. If your infrastructure, if your web tier wants to send something to CloudFront, so index.jsp, give me index.jsp, you want to send bytes or requests back, all the data back to CloudFront, so CloudFront can send it back to end user. What your web server will do is we'll send the first packet to CloudFront and waits for an ACK to come back. If it doesn't come back on an ACK, it will never send the next packet. But as soon as it gets the first ACK for the first packet, it will send 2 packets now. It will wait for an ACK from CloudFront. Means that CloudFront is saying, I've received the packet. Now I'm ready to get more. Now your infrastructure sends 4 packets at the same time. Notice that it doesn't start with 4. It starts with 1, goes to 2, and then goes to 4. So there's a gradual warm-up to this pattern that you send 1, 2, and 4, and you keep going, and if you get packet loss or you get anything else, now you start again from beginning, but the point is that you never start with sending full packets. You send limited packets, and then you increase the number of packets that you send back. Well, as you guys saw, it's a gradual optimization. It doesn't start with full force, and it's a waste of time, especially if you have enough bandwidth between you and CloudFront, and you get connected to the closest CloudFront location, so your bandwidth is great, but what do you have to do this slow start optimization all the time? So the good thing is CloudFront can optimize that for you. Again, as you guys notice, we do have keep alive connections. And one trick with TCP Slow Start is that TCP Slow Start only gets applied to new connections, not the existing connections. So by having keep alive connections back to your infrastructure, CloudFront can now even skip TCP Slow Start optimization. Can skip Slow Start process by having the keep alive connections already open. Let me give you an example. Your end user gets connected to CloudFront. CloudFront goes back to your infrastructure. Infrastructure have to send back data to CloudFront. First packet, ACK of that packet. 2 packets gets back to CloudFront. Another ACK for the last 2 packets. And now you send 4 packets. This is the first user. Now we have a keep alive connection back open to your infrastructure. Now when the second user comes and needs a request makes a request for dynamic content, right away we can send 4 packets. An ACK, and again we can go to 8 packets. So as you noticed, our first user has to go through the slow start process, but the second user can be much more optimized. It doesn't have to go through all that slow start process. I've done a test, Virginia to Oregon location, making a request just directly, second request going through CloudFront, and compare the results. I'll let it speak for itself. Without CloudFront in between, the number of packets I'm seeing is much higher. Each request is about 170 milliseconds. The aggregate of all requests, putting it sequentially, is about 33 milliseconds. Same thing, if I do it with CloudFront, I'm only sending 896 packets. Each request is about 96 milliseconds. And the aggregate of all requests sequentially, the time it takes to do all the requests, about 19 milliseconds. 19 seconds and 24 milliseconds. To speak for itself. Everything we talked about applied to get to get requests. But what about your put and post requests? What can we do about that? What if you want to upload something? What if you have form post? CloudFront can optimize that. CloudFront supports put, post, delete, option, patch. We have all that. We just announced it about a month ago, I believe. The trick with this is that we don't cache the data, so it makes sense. It's a form post for everyone's unique against dynamic request. So we don't cache the content. CloudFront proxies the data back to your infrastructure. And we take advantage of everything else that we talked about today. Keep alive connections, TCP Slow Start optimizations for put and post, and also the fact that you're uploading to the closest CloudFront location. That gives you the huge benefit for uploading large content. And again, the biggest kicker here is TCP Slow Start optimization. Because we don't have to do this window sizing and doing the gradual warm-up of the connection, uploads can happen much faster. Use cases for this would be form posts. So if you have any form posts, if you're doing any posts through forms, AJAX post requests can benefit a lot from this. And also, you can upload to S3 through CloudFront now. Again, I'm going to let the performance test speak for itself. I've done 2 tests, upload directly from an instance sitting in Virginia to an instance sitting in Oregon directly without going through CloudFront. And another test, same test with same file size going through CloudFront. Uploading 10 megabytes of data. Average results for going directly is about 5 seconds. So each upload of 10 megabyte data takes about 5 seconds. It's about 3.5 seconds if I'm going through CloudFront. It's a huge difference. How do I even reduce the download content time even further? How do I even optimize this even further? We can do that with Route 53, and Prasad talked about latency-based routing. Let me give you a quick overview of latency-based routing. You deploy your infrastructure in 2 different locations. You tag it with geographical location, east and west. And what we do is we measure the latency between the DNS resolver of your users to those 2 locations. So the closest location will always win. So when we do a DNS resolution, we send an IP back to your end users that is closest to the infrastructure. It gives you better performance because now your end users are getting connected to the closest location, and also gives you better reliability, and it's really easy to implement and costs much lower than any other DNS provider. This would be an end user perspective, and I'm going to marry that with CloudFront. So this is end user. We'll go to CloudFront. You have 2 AWS regions. Ask for DNS resolution. Resolve me to the closest region. Route 53 has done the test between those 2 regions and knows which one is closest. Will resolve to the closest AWS region. How does that impact CloudFront? Now, what you can do is you can use CloudFront to get connected to the closest location, but there is an origin hostname that you use for CloudFront to go back to your infrastructure. So now what you can do is you can use that origin hostname and point that to Amazon Route 53. And if you have 2 infrastructures in 2 different locations, the origin hostname will resolve to the closest infrastructure. And let me give you an example. So end user will get connected to CloudFront, so CloudFront location. CloudFront says, hey, I need to go back to infrastructure. I need to go back to your origin to get the content. Which infrastructure is the best to go to? Now, Route 53 will resolve you to the closest infrastructure. So instead of going all the way back to the further one, we'll go to the closest one. To give you another example, it's just a better illustration of that. If you have your region is going to be Virginia, if you're deployed in Virginia, a user comes, and it's a user in US, goes to CloudFront. CloudFront wants to go back to the infrastructure, goes to Virginia, so gets the content from Virginia, and responds back to the end user. Now, if you have a user in Europe, gets connected to CloudFront. CloudFront goes to Virginia again. So it's a long haul that has to go and incurs latency. To improve that, what you could do is you can have 2 AWS regions, one in Virginia and one in Dublin. Same pattern again. End user in US goes to, the guy jumps up a little bit. But yeah, it goes to CloudFront. CloudFront goes to Route 53. And then and then Route 53 says, yeah, the closest location to you is US. So you would get connected to Virginia in this case. So this is optimized. What happens to this guy? This guy goes to CloudFront, CloudFront goes to Route 53 and says, give me the closest location. Now, instead of going all the way back to Virginia, the user gets connected, or CloudFront will get connected to AWS region in Dublin. Now you have much lower latency between with CloudFront and your infrastructure. All right, so I think we're almost at the end. With CloudFront Dynamic Content Optimization, I've done everything that we talked about today. I'm at 555 milliseconds, almost not a half a second, but let's shave that off and say half a second now. So we're there. We've done it. We're at half a second. Hopefully I get a raise, $2.5 million in sales. I'll ask. Thank you. A couple of things to talk about, design for failures. We talk about this a lot. So make sure you design for failure. One thing you can do is you can have Route 53, do a health check to your infrastructure. So if you have an infrastructure built, you can have CloudFront to do, Route 53 to do health check between multiple components of your infrastructure. If that infrastructure fails, for example, if let's just say ELB fails, what Route 53 can do is can shift the traffic to the healthy ELB instance. And you can marry that with latency-based routing. You don't have to pick and choose. You can have latency-based routing send you to the closest AWS region. And if that region or ELB or anything fails, traffic can shift to the healthy region. And this may not be apparent to you guys, but caching can be a way for highly available sites. You can cache as much as you can. And what happens is that if there's a failure that happens, I'm going to skip through. Sorry, I'm running out of time. But if there's a failure happens, let's just say the user asks for an image gets served, gets cached, all that is repeatable. Now the second user comes, the content is stale. We have to go back to infrastructure and get it. The content is not, the origin is not available. We can't respond back. We have the object in cache. It's stale, but it's something in the cache. We'll respond back with the stale content. So instead of getting an error message, you get a stale content, which is not that bad. This is the summary. I'm going to skip through the summary, but again, thanks everyone for being here. Thanks for staying all the way to the end. I'm going to let Prasad talk about use cases, but thanks.